Welcome, of course, to this first Embedded World North America that's taking place in Anaheim. I hope everyone's having a great show. My name is Keith Kreischer. I'm the Executive Director of the IoT M2M Council, and I'll be moderating today. I'm joined by Felix Galindo of Digi International and Ahmad Harani of Telit Cinterion. They're going to be speaking, they're the experts, they're the people you've come to hear, so I'm going to let them do as much of the talking as I can. We will be missing someone who was on the program earlier. That's Syed Hossein, who we affectionately call Z. Z will not make it today. He had a family emergency, so it's just us, and we'll get started right now. The subject is AI at the edge, and we've got two experts with us. So I will let them introduce themselves, perhaps starting with you, Felix.
Hello, everyone. I'm Felix Galindo. I am a principal engineer at Digi International. Digi International provides modules, gateways, and IoT platform to provide connectivity solutions for OEM customers. I particularly lead strategy across several product lines, including modules, gateways, and our IoT platform. In addition, I've been focused a lot on implementing our Edge AI strategy and incorporating that into our product lines. I'm happy to be here and pass it over.
Hello everyone, Ahmad Harani, Director of Global Partnerships and Development for Telit Cinterion. Telit is one of the largest Western IoT companies with business units from modules, connectivity, solutions, and platforms group, which is where I sit on our industrial IoT platform side, which is called DeviceWise. And we're working on implementing different AI solutions from our module side to our platforms and connectivity solutions. Happy to be here.
Thanks, guys. First subject we want to get into today, because I think it's one of the major benefits of putting more intelligence at the edge, and that is reduced latency. Applications where literally millisecond turnarounds are required, and I'd like for you guys to air that out a little bit. Talk to us about what applications are out there and how AI is really providing another performance level. Start with you, Mike.
Sure. So some of the applications right now, we're seeing a lot of it, of course, in manufacturing environments where seconds count, milliseconds count, and getting the data to the systems for real-time inferencing is a big factor. Being able to do this at the edge on smaller devices, less power consumption devices, something that runs a little faster, has allowed manufacturers in different spaces to speed their time to deployment. They no longer have to rely on larger infrastructure deployments, heavy server-based GPUs and running network drops all over 100, 200,000 square foot facility. Being able to make these decisions at the edge has become crucial to them, and that's where we're seeing a lot more of the applications.
Specifically, what kind of applications are we talking about, though? Connected car?
No, visual inspection for defect and anomaly detection of products as they're going down the production lines or assembly lines. Different data acquisitions for making sure the process control is on task and people are following the correct sequences.
So industrial process.
Industrial process, yes.
Cool.
Yeah, I'll just add on, I think a lot is true there. Also mission critical type applications, so think of autonomous vehicles, there's computer vision on these systems, and latency is very important there for these type of applications. Also think of medical devices where every second counts if you need to alert or notify of a critical medical condition. So these are just a few examples.
Right. Let's talk about what are maybe some of the downsides. I'm thinking now about constraints on power, memory. How significant are these things, and what are we doing about them?
I would say those are valid issues with Edge AI. I mean, some of these larger models do still require a dependency on cloud. But if you design your architecture, both software and hardware, then you can minimize a lot of these issues. But obviously, you won't be able to overcome every single application by running at the edge. So there'll still be some dependency on running larger models at in the cloud. For example, large language models, they're still very dependent on cloud. So.
Anything to add on that?
No, just again, depend on as Felix said, depend on the application and what you're looking to do. There's always going to be the need, if you're running a large language model in the environment we're in today, it's going to be harder to run that on smaller edge systems. If you're looking to do simple inferencing at the edge, quick analytics at the edge for determining time consumption or process controls, or just a visual inspection for the inference at the edge, those are some of the use cases that do not require those large language models to be physically at the edge. You can run them there.
Right, I get it. Let's talk about power reduction, and maybe I'll start with you, Felix. I should make it clear to our audience, I am probably the least technical person in this room, but I hear that power reduction is one of the benefits of AI and distributed AI, and talk us through that. I mean, how does that work? I would have thought that AI would actually be a drain on power.
Yeah, I would say that's probably a common misconception.
Right.
A lot of these IoT systems have wireless connectivity, and so those can burn power pretty well, right? And so, in all these edge AI applications, some of these are CPU bound, or there's more efficient NPUs and such, and so you can efficiently run these models, not consume as much power, so you don't have to rely on that connectivity to transmit your data to inference in the cloud. So you're saving that power for not having to transmit as frequently.
Right. Is that a matter of bandwidth? I mean, are you saving bandwidth there? Is that...
You do also save bandwidth. For example, one of the protocols I deal with a lot is LoRaWAN, and so there is some constraints on how much data you can transmit, how frequent, specifically in regions like Europe, you have duty cycle limits, and so you can't depend on that connection all the time. So you want to run these models at the edge. So you're better utilizing that bandwidth to be more like alerting, for example, or summarizing inference results, for example. So,
Right. Iman, anything to add? Okay, good. We'll move along. One of the things that comes up a lot when we talk about AI at the edge is just the fragmentation of technology, and that it actually is a contributing factor to that. Do you see it that way, Ahmad? And what's being done about that?
I don't see so much as a fragmentation of technology with AI at the edge. There's just different resources out there to do different processes of what you're looking for from the edge inferencing and edge results of AI. The process is still there. The components are very similar. It's just the edge is not relying on large GPUs. It's relying on NPUs or processors that are capable of handling these functionalities. So I don't necessarily see it as a fragmentation sort of.
Right. But even with different models of AI, large language versus, other forms, agentic AI and more traditional forms.
Agentic AI is going to it uses these large language models, these LLMs and VLMs to do their functionality. So that's that fragmentation. If we're talking, when we look at agentic AI systems, they leverage what we provide them in the LLMs and the VLMs and the different databases. So they're there. So there's not a fragmented. There's multiple different LLMs out there that you can use. So there's different organizations that put out their own different LLMs and versions. So from that standpoint, there is some type of fragmentation. but each LLM that's out there is doing something different, something more specific, and something more related to maybe a specific industry or a specific vertical or use case or anomaly. So you got to be careful what you're using for an LLM for your process and for your procedures. But again, those LLMs are not going to be necessarily running at the edge.
Right.
So we don't have to worry about them from an edge standpoint.
Right. But what about just standardization? I don't want to throw you guys a curveball. This wasn't something we discussed beforehand, but standardization. My understanding is that there's a standards gap when it comes to AI modeling. Is that something you're seeing? And what do you guys think about the importance of standards in this whole area? Is it something that we need to catch up on?
Standards are going to be nice to have in AI. I think over the past, if you think about it, over the past 18, 24 months, all we've heard is AI from the get-go was the thing. Over the last 6 months, we started hearing, well, AI is great, but it's the data that makes it better. Right. So there needs to be some standards as to how you're positioning the data, how you're transmitting it, what things are there. There's just still more out there that I just don't know more to say on that for the standards, but there should be some standards out there.
And we're doing some work in security, for example. We're working with Telit as well as Digi on that, and we're seeing even in things like SBOM analysis, where AI is one of the primary tools. Depending on which agent you're using, you can get wildly different results.
Yeah, it's normal. I mean, you can see right now with some of these chatbots, whether it's ChatGPT or Copilot from Microsoft, you can ask the same two products a question, the same exact question, and you can probably get a different answer or relatively different details depending on what they're querying or what they're using. So there's always going to be AI is not meant to be an end-all be-all tool for everything, right? It's still going to require that human in the loop to make some decisions. We got to be. I don't think today we're at a position to where we can say, okay, here's AI, run with it, and it's going to do everything for you. You can just go home, turn off the lights, and go to sleep. Right. It's not. We're not there yet.
Right. How about you, Felix? Are you rubbing up against standards out there, and what are you seeing in terms of?
I think I agree. I mean, it's still too early. I'm not seeing any particular standards. I think it's difficult still to standardize, especially with sensor-based edge AI. I mean, I could see more on vision and audio and those types of things, but with sensors, you have temperature, you have vibration, you have just so many types of sensors. So it's still pretty early to be able to standardize that, in my opinion.
I want to shift gears and talk about, I'll go to you first, Felix. You're on the hook.
Yeah.
Talk about cloud dependence. I hear a lot about it. Is it just a sort of a zero-sum game where by reducing, your need to communicate with the cloud for certain things, you're picking up memory, power, and other resources elsewhere? I mean, why is cloud independence important?
It's going to be. It's important just because you obviously, in certain situations like mission critical situations, you don't always have that connectivity, right? You can't rely on cellular networks or a LoRaWAN network, for example. I mean, you have to be able to run these types of decisions and inferencing at the edge, because some of these applications just need it, right? So I think, obviously that means you probably need a different hardware architecture or something, but yeah.
Right. Ahmad, Telit does soup to nuts. You guys have networks. You have, really from every layer of the stack, you have something to say. So, thinking about cloud dependence.
Cloud dependence. So the reason why cloud independence is going to be important is you got a lot of organizations that do not want their IP, whether it's an image, a script, or anything, leaving their four walls. So they're not going to be focused so much on the cloud portion as they are on having things deployed locally within their infrastructure. And to Felix's point as well, that connectivity piece is going to always play a role. And the bandwidth of your network or of the cellular capabilities in the area you are, all that plays a role. So the dependency on the cloud is shifting from having it all in the cloud to making it more localized in specific installations. Cloud's always going to be there. There's always going to be a need to have the data going to the cloud. If you're a smaller organization and you're not willing to invest the thousands of dollars needed to run a GPU server farm in your place, you're going to need to go to the cloud first. So there's always going to be a cloud aspect there, but there's independency in it as well.
You know, since I've got you, and again, not to throw a curveball, you know, I hear a lot of talk about heterogeneous networks, headnets, you know, and how AI can help in the management of that. Is that something that Telit is a proponent of, or?
I don't know. I'm not involved in those conversations from the network side and what's going on that standpoint. But it's probably something that I'm sure some of the teams are discussing and talking about.
I know there's a lot of network operators out there that are talking about it, so I thought I'd ask. But let's move on and talk a little bit about, you know, one of the big applications out there is digital twin, and obviously AI is a major component in that discussion. You know, it's allowing simulation, it's allowing predictions, you know, to take place, enabling service level agreements. Talk to us about applications for that. I mean, what's out there? What's it being used for now?
It's being used for a lot of different purposes. Where there's a lot of sim to real applications being handled and simulations done from large industrial settings to smaller settings. What some organizations have done right now is they're taking the data they have from one of their existing facilities, putting it into this digital twin environment, and simulating changes. If I move this line over 2 feet or move this process faster by 3 seconds, what is the overall impact on the entire process and the entire system? And they're able to determine all this and run multiple different variations in a short period of time with this digital twin environments, and simulating this data, and then taking this simulated data that they've tested in this environment offline, not impacting their process, taking it and putting it into real life use cases and seeing the actual benefit that they saw in the digital twin. So it's the translation is almost a one for one in that process.
Right. Felix, talk about Digi in this regard. You know, I'm sure you guys are seeing the same thing.
Yeah, I mean, I guess one of the issues I've seen is a lack of actual sensor data to be able to train AI models. And so, you know, to Ma's point, you know, being able to simulate a lot of these applications is important. For example, we're working on an agricultural use case where this amount of data that we're collecting has never been done before, and what we're trying to predict, I mean, it's just, there's no research studies on it, there's nothing to rely on, and so we have to rely on simulations or you know, really mathematical models to be able to do that. So just the lack of data is complicating things. I think digital twin, it's helpful in that regard. We just don't have as much data for these sensor-based applications.
Is data quality an issue? I mean, when you do get data, is that a problem?
For sure. I mean, there's tons of applications I've seen where we have large amount of data, and you know, with supervised learning or machine learning, you need labeled data, and so you know, there's customers gathering data for months and months or even years, but they're not labeling their data. So that, in my opinion, that's bad data. If you don't have a label and you can't use it to train your model. So.
Right. Ahmad, talk to us about data quality, but I also want to talk about scale. You know, when it comes to digital twin, you know, I'm told that's something of a constricting factor.
You'll have to tell me why. Eventually talk about that. Data quality is 100% important, and yes, Felix is right. There's a lot of organizations that are just collecting data with no labels, no nothing. In our instance, because of with our software, with DeviceWise, we're able to collect this data in a structured format and have good quality data coming into the system that we're able to feed back into AI agents to perform whatever functions we want it to do. Because of the structured nature, the quality is there. We have this amount of data. But if you're getting it in an unstructured format, no labels, no tags, no context to it, Felix is right, it's just bad data. It's not going to do you any good.
Right. The scale point.
The scale point, yes.
I'm just parroting what I've been told, that sometimes it's difficult to scale digital twin simulations for large-scale deployments.
I got to disagree.
Yeah.
Your digital twin is a scalable model for you. You're creating that digital environment of the physical aspect.
So the digital twin is providing the scalability.
It does provide scalability because it allows you to see things in a closed environment without having to invest money up front to build something, right? So you can see it in whatever. Again, it's theoretically a one-to-one scenario. Right. So the scalability should never be an issue.
No, your answer makes sense because that's why you're doing a digital twin, is precisely for that reason. Okay. Again, shifting gears, I want to talk a little bit about security and how digital AI will impact on the security of IoT deployments. I've been told that having localized security and localized privacy functionalities is actually really important. Explain to me why and how that works in real life.
So yeah, security is definitely important for any IoT deployment, whether it's AI based or non-AI based. You always want that security level, and that's why when we build our modules and all our systems, there's an inherent security piece in there. And when you're communicating over cellular, there's also an inherent encryption built into cellular communication, so you don't have a large concern about security from that standpoint. Why is it important with AI, or how AI helps? It's because of the sensitive data that could be transmitted through it, whether it's mission critical data, highly important data that is secretive to that organization. They want to keep it secure, to keep it safe. So there is a lot of security functionalities, but again, I'm sure Felix will agree, when we design these systems, security is designed, built into the modules, built into these gateways, built into the stuff that helps. But it's also putting different systems on someone else's network. The network has to be secure as well, which as a third party, you don't have control over that network. You can help make recommendations to influence, but that's where it is. So.
Right. All the relevant layers of the stack need to be covered by security in order to really be secure. I guess it's the point. Felix, anything to add there?
I think you covered a lot, but yeah, wireless connectivity, that's usually secure by nature, right? So it's designed that way. So usually that piece you don't have to worry about. But if you're sending data to the cloud for inferencing, you have privacy concerns there. A good example is just computer vision, right? Think of your doorbell camera sending, constant video streaming to the cloud. You probably don't want that. You want it to run these AI models at the edge. Yeah. And so that's just better for privacy overall.
Right. Before I let you go, regulations. We're seeing CRA in Europe, NIS2, RED. The U.S. we've got the Cyber Trust Mark now, which is covering consumer product. Japan, JC Star. The list goes on. How do you see new regulations, a new landscape in the regulatory front affecting the deployment of AI at the edge? Is it going to be an issue?
I think eventually it will be an issue. I think regulatory, they still need to catch up a little bit. So I think we're still pretty early in edge AI. So I do see that being something significant here in the next maybe a couple of years or so. But immediately I'm not seeing anything pop up yet.
I'm living and breathing it. So I also want to talk about costs when it comes to security. I mean, there's always a trade-off, you know, to make something more secure. It's liable to cost more, and you know, how do you see that playing out?
I mean, it's anything, you know, requiring engineering effort is always going to be a cost. So, and security is always a big one. Customers demand it, so it is going to be a significant cost down the road.
So it's built in, though. I mean, is what you're saying.
Right.
Right. Yeah. Talk to me about open standards. I mean, it seems like open standards are something of a double-edged sword. You know, by exposing firmware to more people, you're making it safer, allowing people to have input and to make something intrinsically safer. But at the same time, you're exposing things to people who might have bad motivations, and you know, it's something again that I'm personally dealing with a lot right now. You know, talking about standards and regulations, and I'm just wondering if you guys have thoughts on that. Open source is a lot of firmware is open source, and you know, do you see it the same way I do? I guess is the question.
So yeah, the open source you're right, it's a double-edged sword, but it's also part of the security functions we talked about, right? When someone getting a hold of the firmware code and manipulating it, it's only going to likely affect the product that they're working on because of the security you've built into your system. If you don't allow that transmission back in, it's not going to affect it. So security is playing a big role in the open source. But open source is also great because it allows us to expand and use things that you couldn't normally use or get hands on from private entities, right? So there's risks and rewards to the open source.
Right. Yeah. Again, something we're seeing. You know, trying to provide SBOM monitoring services, and we see, you know, people showing a little resistance to that for the simple reason that they don't want their firmware out there anywhere.
Correct, and that's a lot. It's happening a lot in Europe with the different regulations and all that. You mentioned the CRA in Europe, and a lot of right now those regulations are tied to highly documented processes. Right, it's you got to document what you're doing to support this feature of CRA or this function of the regulatory requirements, and that's part of that integrity piece that everybody's working on.
Right. How significant is it to have localized security and privacy functions? Is that something that's making us more secure? I would imagine it is.
It definitely. I mean, the more things are secure, the more secure you are, right? It's that additional layer of security. Think about it from your multi-factor authentication as you're signing in to specific websites, right? You put in your username and password, and it's going to require you to submit a secondary code or pretty soon a blood sample to make sure that you're the right person. So there's different ways of that, and security is always going to be a priority a top priority of a lot of folks, a lot of people, and even from a privacy concern, from privacy standards, even consumers want their privacy, want their own information secured from nefarious actors. So we're always going to have a security conversation around anything and everything we do, right?
And it's like I said, the regulation is just bringing it sort of front of mind for a lot of people. Although at the same time, you know, many of the people who are deploying IT technology, you know, aren't up to date, up to speed on what's coming down. And CRA will be with us in effect next year, so I think a lot of folks will need to become more aware.
It's part of the education process that we need to
do.
No, I was just going to add on. I mean, you know, firmware updates for a lot of these modules, you know, a lot of the modules we build at Digi. I mean, we need to provide mechanisms to securely update firmware. And related to Edge AI, a lot of these models are baked into the firmware, but there is work to be able to update models independently, and that opens up a lot of security issues as well, because now your model also needs to be secure. It needs to, you know, have signatures and verification of the signature at the edge in order to be able to update these models.
Right. Right. I'm going to shift gears. I'm not going to let you go, Felix. I want to talk about business models and predictive. Predictive analysis is something that, of course, AI is very much a part of. Give us some use cases that Digi is working on when it comes to predictive analysis and how that's actually providing ROI.
Yeah, I would say, I'll go back to the agricultural example. To go a bit in more detail, it is a product that's monitoring cattle health in the field. And so, if you're aware, cattle is going to develop certain diseases and develop fevers. And so with Edge AI, we're able to predict when cattle are getting sick and notify farmers so they can take the appropriate actions. And so, imagine a cattle, some of these are worth a couple grand or so. So if you have a field of, say hundreds of cattle, you're saving quite a bit of money from preventing other cattle from getting sick. And so that's a pretty interesting use case here at Digi that we're working on. So.
Great. Ahmad, I'm sure Telit's got some use cases over there.
We do. I love the cow one, so that's great. It's interesting. It is an interesting use case there. So some of the things that we're looking at when it comes to the predictive nature of analytics and AI at the edge is organizations in manufacturing are struggling to do predictive maintenance and preventative maintenance on their systems to keep them running. So using Edge AI capabilities to collect this data, and we announced a few weeks ago our intelligence suite that's adding fault recovery analysis into the mixes. As we start collecting all these fault codes into the system, we're able to help the systems recover either with human intervention or automatically based on the process that you put in place. So we're helping return a lot of time back into the environments, avoiding the downtime of system functionality from lack of maintenance or anomalies in the power consumption that may be coming through. You see a spike in power that usually means something may be off. Or if it's looking at a vibration sensor, the vibration on a motor has gone into a red area that's ultimately going to lead towards some type of failure in the future. The sooner you're able to get ahead of this stuff, the faster you're able to prevent it.
Right. Is ownership of the AI model, is that an issue for Telit?
No, because the way we've developed it is the customer has full control over their models. They're able to, the end user designs, builds their model in-house, and they can manage it as they see fit. They can update models, they can retrain models, continuously let the models evolve. So
once it's generating new versions of itself, so to speak, that's all under the ownership of the customer.
If it's their model, yes, absolutely.
Right. Felix, and I assume that Digi is much the same.
Yeah, I would agree with that. We do want to provide an option where we can develop models for our customers to facilitate generating these models, because it does require a certain expertise. In the end, it's their data, it's still their model, but we can help facilitate deployment of those models through the infrastructure that we're building for Edge AI across our product lines.
SLAs, you referred to them earlier, Ahmad, service level agreements. Talk us through. I'm sure Digi has some of those use cases as well, where people are doing predictive maintenance on machinery that are in the field, and you're facilitating that. Just talk to us about that a little bit.
Traditionally, that's been more in the cloud, but as we're getting more into the edge and Edge AI,
Okay.
We're definitely getting more involved there. I think it's still an early point for Digi, I would say, on that, but
Right.
something we're working on.
Right. Ahmad, we hear a lot of, we've been hearing about predictive maintenance for a long time. You talked a little bit about it. Are there specific use cases that you're allowed to talk about?
Unfortunately, no. In general, predictive maintenance is key for anybody that has any type of environment that's using machinery or to collect data, to build something, to manufacture something. Predictive maintenance is always going to be key to avoid downtime. Downtime costs money. The bigger you are as an organization, your permanent cost is larger. You look at large automotive manufacturers, some of them value their per minute rate at over $30,000 a minute, right? So being down for a minute costs them $30,000.
I'd imagine that equipment manufacturers look at that as a revenue opportunity.
They do, and we partner with several equipment manufacturers for a connected things applications where they're able to remotely monitor their systems, and so 9 out of 10 times they're able to pick up the phone and call their customer and say, we've noticed an issue on your machine. So that's part of that. AI is helping them analyze this data a little bit more, put it at the edge and analyzing the data more so they can now try to predict some of the future failures in that as well.
Right. So we've talked about a lot of the benefits of AI, reduced latency, reduced power reduction, cloud independence, localized security, and now predictive business models. I'd like to open it up to the folks who are attending. Has anybody got questions for our panelists today? You got one? Please.
Related to model security, do you guys see like protecting your model's IP and reverse engineering as a threat? And are you doing anything about that?
When the model is done by the end user, when they control their model, it's controlled and secured by them, right? It's in their system. Reverse engineering the model in what way? I'm not sure.
I'm just thinking like in Edge AI, the hardware is out in the field. It's subject to maybe more inspection than it would be in the cloud system where you have limited access to the actual physical storage of the model.
That's part of the security that's built into the systems that you'd have to encrypt data, right? So I don't see it as a major concern right now. Felix?
Yeah, I would say, all these models lie in the same area where your firmware lies, right? And so the firmware by nature is already secure. Certain areas of flash, for example, they're already secure. And so it's just, I guess, Edge AI models just inherit the existing security infrastructure, at least in the Digi modules and SOMs. So.
Great stuff. Anybody else? Question? We got one down there.
I was kind of curious what you're doing about sort of full life cycle, remote management of all aspects of that edge device, being that it seems, you might have a communication controller like a cellular module, it's got its own firmware, you've got your firmware of the device itself that, I don't know if you're letting the customer customize that or if you're providing it. And then you've got the models, which are probably going to iterate over time. The models are going to continue to have flaws, be retrained, be redeployed. How are you handling all of that through large numbers or fleets of devices?
Yeah, I think that's a really good question because it's an area where I'm really interested in. I think, there's lots of vendors out there providing pieces of the Edge AI puzzle, right? You have, platforms like Edge Impulse, you have TensorFlow, you have all these silicon vendor tools that are providing models, but I think we're missing the whole big picture, which is Edge AI infrastructure, to be able to generate training data, whether it's through wireless connectivity modules, and then be able to retrain these models and deploy them back on the edge to update, because these models are going to evolve. There's not especially in sensor-based applications where maybe you're trying to monitor, say, a motor, each installation of that motor can differ enough that your model needs to be different. So we're almost going towards personalized Edge AI models. So you need to be able to update each instance individually. And so Digi, that's part of the work that I'm working on, is just to facilitate all the way from data acquisition, training, all the way to deployment and managing of the models. So there's some interesting stuff coming from Digi on that aspect, I would say.
Matt, anything to add?
No, similar to what Felix said, our teams are actively working on model deployment, model management criteria for these edge deployments, and making sure that we're looking at the different firmwares and software versions, et cetera. So it's things that are under development currently. But it's a great point.
Do we get to your question?
Yep.
Great. Any other questions? With that, I will ask each of you guys to leave us with a parting thought, just summarize and a conclusion. Yeah.
So we're all excited about what AI can do for us in different aspects of our lives, and even different aspects of our businesses and our customers' businesses. So we tend to think inside of four walls or inside of a box when we're talking about applications and things that we can do. The nice thing about AI is it now allows us to think of what's possible, right? The art of the possible has now become even more functional and more deliverable with some of the tools that we're seeing from AI and what AI can help us do. It's not going to be, again, we're not at a point where we're going to turn on AI, turn off the lights, go home and sleep. We're not going to get there. I hope we never get there, to be honest. But just keep your eyes open. Keep your minds open to the art of the possible and what can be done there, and have fun with it. Enjoy what you're doing. We're here to help in any way we can.
Great, son.
Yeah, I mean, to close off, I mean, I would say, just go back to the Edge AI infrastructure. I think that's just an important piece that needs to be solved. It's good to hear Telit's also working on that. They're just working on that just to be able to facilitate, being able to use Edge AI in customer products. I mean, it's just something we're working on. So the easier we can make it to deploy Edge AI, I think the more solutions we're going to see, and not just that, but solutions that can scale and continue to grow. So I'm excited myself for where Edge AI is going, and I think we're still pretty early.
Yeah, it's going to be interesting times, that's for sure. Ahmad Harani of Telit Cinterion, Felix Galindo of Digi International, thanks so much for your time, for joining us, and I'd encourage anybody who would like to establish contact to just come up to the podium, and we'll stick around and answer a few questions. Thank you.
Thank you.